Maaf, ay anjinay.
Last episode, k-means found 4 customer segments from 0 labels. But I showed you 2 shapes where k-means completely breaks.
A crescent dataset, and a cluster wrapped in noise.
K-means slices the crescent wrong. It lumps the noise in like it belongs.
Episode 24 fixes both of those. 2 algorithms, 2 different ideas, one after the other.
Hierarchical clustering and DBSCAN.
Hierarchical clustering starts with the simplest possible idea.
Every point is its own cluster. Start there.
Find the 2 closest points in the whole dataset.
Merge them into one cluster.
Find the next closest pair, could be 2 points or a point and a cluster. Merge again. Keep going until everything is one cluster.
That history of merges is the dendrogram.
Here's the dendrogram building itself, merge by merge.
Low merges at the bottom, nearby points joining early.
Tall merges at the top, distant groups finally connecting.
To choose K, draw a horizontal line across the tree. Count the vertical lines it crosses. That's your K.
No elbow curve needed. You see the structure directly.
Remember the crescent dataset k-means sliced wrong?
Agglomerative clustering with word linkage handles it cleanly.
Word linkage minimizes the total within cluster variance at each merge. It hugs the actual crescent shape instead of cutting across it.
Same data, completely different result. DBSCAN stands for density-based spatial clustering of applications with noise. 2 parameters. Epsilon, the radius of the neighborhood. Min samples, how many neighbors a point needs to count as core.
Core points have enough neighbors inside their epsilon ball.
Border points are reachable from a core point, but sparse themselves.
Noise points are neither. DBSCAN labels them -1.
No guessing K. No assuming round shapes. Noise is its own category.
Now the dataset k-means struggled on. Tight core, scattered noise. DBSCAN marks the dense core as one cluster.
The scattered points around it? Noise. Label -1.
K-means would have dragged those noise points into a cluster.
DBSCAN just says, that's not a group. It's noise.
So how do you choose between the 3?
K-means fast, simple, works when clusters are round and similar sized.
Hierarchical, no K needed up front. Dendrogram shows the full structure. DBSCAN finds clusters of any shape, handles noise explicitly.
Hierarchical is slower on big data. DBSCAN needs careful epsilon tuning.
But on the shapes k-means gets wrong, both beat it easily. In code, both fit the same sklern interface.
Agglomerative clustering set n_ clusters and linkage.
DBSCAN set eps and min_ samples. That's it.
Both expose a labels underscore attribute. Same pattern as k-means. If this clicked, subscribe. PCA is next. A few mistakes come up constantly here.
Using word linkage on data that isn't scaled, distances dominate.
Picking epsilon for DBSCAN by gut feeling instead of a k-distance plot.
Treating DBSCAN noise label -1 as a real cluster.
Running hierarchical clustering on a million-row dataset, it's O(n)².
Using DBSCAN when density varies wildly across the dataset.
Quick recap. Hierarchical. Merge from individual points up, then cut the dendrogram.
DBSCAN core, border, noise. No K. Any shape.
Both handle what k-means can't. Scale features before hierarchical. Tune epsilon carefully for DBSCAN.
Read the noise label -1 is not a cluster.
Episode 25. PCA, Principal Component Analysis. High-dimensional data visualized in 2 dimensions.
We've been clustering in 2D. Real datasets often have hundreds of features.
PCA collapses that into something you can actually see.
Subscribe so you don't miss it. Challenge task. Take any k-means failure dataset.
Run both algorithms. Compare the plots. Write 1 verdict sentence. Solution in the repo. The crescent k-means sliced wrong. Hierarchical hugged it.
The noise k-means lumped together. DBSCAN labeled it -1.
Different shapes need different tools.
Episode 25, PCA, drops next. Subscribe. Where did k-means fail on your data? Drop it in the comments.